My name is William Front, and I'm going to build a PC in partial compliance with TRECA requirements for a certification to teach the hardware component of Cisco certification. The components in front of me are the basic components of the PC, and what I'll do is I'm going to take this piece by piece, put it together, and then run the PC, as well as installing the operating system. So what we have here is on the right hand side is the case covers for the case, which is on this end up here. And then following that are optical drives, a floppy drive, the ribbon cables for both the IDE optical drives and the ribbon cable for a floppy drive. Behind the optical drives is the hard drive that will be in this system. Now there. It will be connected using SATA as a SATA cable connection. There is our two memory chips here, which are both DDR800 1 gigabit memory sticks. Our power supply, which has been rated for the components that we have within our PC itself. The rating on most power supplies can be read on the case itself, saying how many watts it'll run for. And this is a 350 watt power supply. So that's more than sufficient for the components that are in this PC, but it's definitely a consideration when building, as are all the components, because they have to match and they have to fit. The motherboard itself is a Gigabyte GA945 GSM SC2 motherboard using LGA 885. And the CPU itself is an Intel Pentium Core 2 2.83 gigahertz processor. The case itself is a standard PC, generic case, used for any number of applications. A lot of big companies use these generic cases. The gray and black replaced taupe in the middle 2000s, or early 2000s anyways. So those are the components, as well as the CPU fan that's behind the, in the video, behind the power supply itself. The first task in any manipulation of electronic components should be to ensure that you're either grounded out or you've got flat ground. I'm running this on a wooden table, which is dielectric. The components themselves are dielectric, and I'm standing on a shock-resistant mat. So normally what you do when you're establishing or building a PC is you would put on a surge suppressor, or you put on a surge suppressor, an anti-static strap to your wrist, or to another component of your body, or working on an anti-static mat. In this case, I'm grounded out I'm ground neutral due to the environment that I'm in. So I'm going to forego the static strap for this build, and the first step is to mount the motherboard in the case. Prior to mounting the motherboard in the case, you need to see where the mounting points are, and to put brass standoffs in the case. I'll lift into this case. What we can see is the standoffs are now installed, and the case itself is ready to receive the motherboard. That's an image of the standoff itself. There's another one. There'll be more down here in the corners of the cases and on the sides. As we can see inside the case itself, the brass standoffs are in place and ready to receive the motherboard. That way, what will happen is the reason we put the brass standoffs in there, it's not that brass is electrically neutral, but it does less damage than steel does, so it's less abrasive to the motherboard. And what it does is it gives space between the case itself, the metal case, and the motherboard, which is basically a large grid array of different circuits. In this case, I also added a CPU fan in here because I'm going to put a higher end video card, and I didn't want to rely simply on the power supply's fan to cool the case. And here you can see the CPU is now mounted in the case. It hasn't been screwed in yet. but it's mounted in the case to ensure that the standoffs are below the screw heads, and that the motherboard itself is not going to be shorted out on the metal case. Okay, so now we have it screwed in and it's ready to receive its components to make the motherboard complete. And so the next step will be to put the CPU in its socket, which is like an LGA socket. It's a land grid array, and after that's in, we'll put some thermal grease between the CPU fan and the CPU itself, so that it can transfer heat, not overheat, and be able to service the processing that's needed for this component system. So those will be the next two to go in. Okay, so the CPU is in. The CPU fan is on its place with thermal grease as a transductant or to transfer heat, and then between the fan itself and the heat sink that's on the CPU fan, and then the 4-pin fan connection has been made. And so the next step for me is to make some more connections with front USB ports and rear USB ports, and to install the front cable switches, or the cable for the front switches, like the power and the reset and that sort of thing, and the hard drive light. It seems that most of the time when people are assembling CPUs, that tends to be the #1 thing that messes them up, because the color coding isn't always consistent. Even though there is a standard, you have to actually read the connectors and then read the motherboard and make sure that the two of them match. The next step in building a PC is putting the power supply into a raw case like this. So what I'm going to do is I'm going to put the power supply in. I'm going to run its cables to the general areas that they'll service the hard drive, the floppy drive, and the 2 optical drives, as well as the video card that I'm going to install in this case. So that's our next step. It's 4 screws. Usually that's like anything else in the CPU when you're building one, or inside the case of the CPU. You try to go with as close to 0 insertion force as possible to ensure that you're not crushing, breaking, stripping, and ruining things that cost money. And usually when I'm constructing a PC or building a PC or even servicing a PC, once I've gotten inside of it, I usually find that the cable layout isn't what I wanted it to be, and what I like it to be is as open as possible. And sometimes that requires that this bigger bundle here, the components of it be not twisted, but not twisted to the point of breakage, twisted together so it holds a tighter space and allows for better airflow. Especially when you're using higher end video cards and other components, they're going to tax the computer itself. So like I said, I like those things to be nice and tidy. In this case, what I'm doing is I'm putting the whole cable bundle from the power supply off to the side, and then evaluating what components are going to go in next. So I'm going to install the optical drives, the floppy drive, and the hard drive, and their associated cables, and then I'm going to connect the power supply connections to those drives. But first, I'm going to get the ATX connector, which is the big connector on the motherboard, there by the purple IDE connector for the optical drives, and the P4 connector, which basically is a component to tell the power supply that there's a legitimate motherboard installed and when to actually deliver power. So those components will go first, and then I'm going to put in the optical drives. Okay, now you can see that the 2 optical drives are installed. I took off the faceplate of the CPU so I could get those optical drives in place and evened up to where they'll be on the front of the CPU. And the hard drive is physically installed, and the floppy drive. So the next thing to connect is the IDE cable and the power cables and the SATA cable. The IDE cables to the optical drives as well as power. The Bird connector, which is a 4-pin Molex connector, which is similar to these 4-pin Molex connectors, only smaller. That's a Bird connector. Goes on the floppy drive. And then our SATA cable has SATA connections to support SATA operations, and a actual SATA data cable. So there's a power cable for SATA, and there's a data cable, and I'm going to connect all those next. Okay, All that remains is the memory chips to be installed and the video card. And once those are in, I can close up the case and it should be good to go. That's basically building a PC. So I'm going to put in the memory chips, and then we'll take another look at it, and we'll put in the video card and boot it up and get an operating system on it. Okay, everything's tight and secure. The memory cards are in. The latches are in place, holding them in. The video card is in. It has its own power connection at the back end, which is important because if you overload the video card, it probably won't start with modern video cards, but with older stuff it can overload the motherboard and cause a burnout, basically burn out a slot. So everything's connected and ready to go. Now it just needs to be, the case needs to be shut up and locked down, so that's the next step. This is a completed CPU, nice tight case, 2 optical drives, a floppy drive, which obviously today isn't necessary, but it does cover some more of the arcane deals with support for PCs. Our case here has 2 DVI outs and multiple some legacy connections here with a PS2 and a parallel port LTP1 to support a parallel cabled printer. So that's the machine, and our next step is to fire. CPU booted. It's a 2.6 gigahertz E5300 Intel Pentium dual core processor with the gigabit 945 GCM S2C motherboard. And so let's check some error. It typically happens when you boot up a fresh motherboard. Also, this motherboard does not have the CMOS battery on it. So what I'm going to do is I'm going to press F1 to continue, and I'm going to load the operating